Hi everyone, in the last video we have seen that how to create a linked list. For today's session it's very easier. So let's get started. I'm going to use Genie editor. You can see the entire file is a new file and there is nothing opened over here. So let's get started with hash include stdir.h. This is standard input output.h. I'm going to create hash include standard lib.h. With this I'm just going to save this to some better place. I'm just going to create a file named InsertNode.c. So after having this extension, you can see the entire color has been changed. So let's get started with our initial function, that is main function. Pretty much easier. For that I have to create one more thing, that is node. In the last video you have seen that I have created a node for it also. So this is the secondary task. I'm just going to create the same node over here, integer struct node star on the side star node. Fine. So this is how I'm just going to use it with same functionality. So just a second, I'm just one thing, star of next. So this will be pointing it. You can see the entire things are also getting populated in this thing also. So let's see how I'm going to create it. So first, for that I need to create one more thing, that is a head node. So I'm just going to create struct node star of head. Okay, so it's pretty much simple, you can see, but I'm just going to initialize it with null for time being. Then we will see how we are going to append the things. Let's see. So I'm just going to create one more function, that is append and 4 comma head. So what I'm going to do over here is I'm just going to initialize a new space for this thing, fine, and insert a new node, that is head node, fine, with a value of 4. For that, just reading some comments for you people. If you like it, you can see it over here. Fine. So I think that you can prettily understand this thing also. So for that, let's create a new function named as append function. Okay, so from the beginning I'm just going to create one function named as append. You can see I just passed two arguments. One is head and the another one is 4, that is an integer. So the data type for this head is, you can see it over here, it's struct node star. So I'm just going to create struct node star comma head, and with that I'm just going to create integer data. Fine. So this is the data which I'm just going to create it, but instead of data I'm just going to write new data so that it doesn't actually conflict with this name right now, for understanding. Otherwise it's okay if the name is conflicted in this function also. Fine. So I think you have got this thing till now. If you didn't, please pause a minute and once again go back and understand this much. So I'm just going to create a new node for that, and I'm just going to create struct node star. Just a second, I'm just going to explain you what I am typing right now. Size of struct node. Fine. So what I have done in this function is, not to worry, I didn't do much of the thing. What I'm going to do is I just want to allocate some memory location for this new node. So for that I'm going from the inner function to explain you people. This function will actually return me the memory or bytes which are going to be assigned runtime in the heap portion. So what I'm going to do is struct node is an argument for size of function, and this size of function will give me calculative space, fine, and this calculation will be given as an argument to malloc function. Malloc function is a function which is going to allocate some memory allocation, this mloc, or you can say it malloc, whatever you like it. So memory allocation is being done from this argument which is given to it, fine, and whatever the memory allocation is, the return of any of the things from malloc function is being typecasted to struct node star, because we are going to, okay, just typing mistake, sorry, we are going to use this struct node function variable in some time, fine, I hope so. Okay, done. So after that I'm just going forward. You can see append function and everything is being populated over here also simultaneously. Struct node star, fine, I'm just going to create a last node, that is head, fine, assuming that this is the last node right now for time being. I'm just going to type new node equal to new data, fine, but new node of data, sorry, new node of data, that is when I'm just going to create some memory location, it does consume two things, that is data and next, fine. So what I'm going to do is new node of data is equal to new data, fine. So whatever I have just given it over here is going to pass to here, and then it's stored in this variable. You can see, I think it's pretty much easier to understand in this context. So after that, new node of next is equal to null, fine. What I'm going to do is point this pointer to null, fine. Okay, so let's see what is our next step. So after that, if head equal to null, in this case our linked list is the primary linked list, that is it doesn't contain any of the node up till now. So in this case head equal to new node, fine, and then I'm just going to type return head, fine. So if the head of this struct node is null in the initial case as it is right now, so it's going to create this data, fine. After creating, it will replace the head with a new pointer location and then return the head, fine. For that, returning the head, you can see over here head is having data type of struct node star pointer. So I'm just going to type struct node star because it is a pointer and having user defined data type of struct node, fine. So after returning this thing, you can see over here it's going to return this head to this, and the entire memory location is going to replace it in this manner. So let's see. Okay, okay, so let's finish it with print also, fine. So void display while, let's print it for time being. This function has been already covered in my previous video, so do not worry, fine. If you haven't watched my previous video, you can watch it. So while printf %d comma node of data and then node equal to node of next. I think it's going to work. Let's see how it's going to. Let's build this portion. Okay, just a second. I'm just okay. So some of the errors. Let's correct this thing. Very pretty much smaller errors over here. You can type this way or you can also type this way. Doesn't matter. So okay, I'm just going to pass some values. Struct side struct node star node. Fine. Okay, so also one more thing, I'm just going to return some node. So in this if case, return head is I'm just going to return now, right now for some time. After that we will see how it's going to go work. Okay, let's compile it or build the entire project. You can see this is some warning. We will take care of this warning afterwards, but as of now it's going to work fine. Okay, so let's print it. I'm just going to print this thing. I'm going to display and then going to pass this head with it, and also return some value to compiler. You can return any value, it's not necessary that you return 0, but it should be an integer. Let's build. Okay, compilation failed. Okay, just a second. Oh yes, there's some error. You can see it over here on line number 9 that it says I just forgot to put this thing. Silly mistake. Okay, so let's see. So you can see over here now its compilation has been successfully finished. Just ignore this warning as of now because we have not used the entire this value. Let's see. So you can see 4 has been inserted at the position where we like it, that is at the initial position. So after that, let's try with insert function also. I'm just going to create one more function, that is head. Okay, but before that, let me finish this one also, right? Because append has been partially done, not fully. It's going to insert at the first position only, but for that right now let's append it in this way, while for last of next is not equal to now. Fine. Unless it's not equal to now, I'm just going to create a looping structure for the position where we want to insert it, last of next. Fine. So this will what it will do is pretty much easier to understand. Append always inserts the node at the last position of anything. Fine. If you say I'm going to append a line, it's going to insert the line at the end. So in this way, I'm just going to insert any node which is going to come at the last position. Fine. So let's see how we are going to do is not equal to now, last of next equal to new node. Fine. And then return head. Pretty much easier, huh? Fine. So what I'm going to do is create these sequences in this manner. So you can see it, there are 6 steps for doing this thing. This is the first step. Fine. This is the this is the second step that I'm going to do is just a second. This is my second step. I think this is my third step. After that, this is my fourth step. Easier to understand. This is my fifth step. And again, this is my sixth step. So you can see I have inserted each and everything in just 6 steps. Easier to maintain. Fine. So this will append the entire thing at our busiest position, the way we like it, that is at the end. Fine. I'm just going to create some spaces for this thing. I'm just going to fulfill this comments after some time. Fine. So append is much easier. It's just in 6 easy steps. Eureka. Fine. Sorry. Fine. So, okay, so I think it's been structured in a very good manner. So after that, let's understand how to insert a node. Fine. Insertion is done at any point at any location. Fine. So let's do it at this position. I just want to insert one at the beginning. So the linked list would become, okay, I'm just not going to insert one, but I'm just going to insert two at certain position. So the linked list might become something like this. Sorry, no, so this is how it should look. Fine. Let's see, but before that, let's compile it one more time so that the errors goes away. And you can see the error has been gone. Once again execute it, so you can see 4 is being inserted to our linked list. Fine. So let's append it and not insert it in this moment. Insert head comma 2. Fine. So in the similar manner, I'm just going to struct node star, going to insert some function, struct node star, node comma new data. I'm also going to return head at this position. I'm just going to use this as a head as of now, because I'm just passing head in the main function. Let's see how I'm going to do. Pretty much easier. It's being done in just 4 easy steps. Let's start with newest step. So in the very beginning, always the first step comes with creating a new node. That's right now I'm just going to do it. So struct node star. Fine. And then I'm going to use malloc function, size of function, struct node, and then this is my first step. You can see. Fine. So what's my second step is allocating this new data. Oops, sorry, I just forgot to type integer. This new data to this location, this node. Fine. So let's do it with that thing also. Node of data is equal to new data. Fine. So the new data has been inserted to new node that we have created at this moment. Fine. So this is my second step. Fine. After that, I'm just going to type node of next equal to head. Fine. So what I'm going to do is I'm just going to check for the location where it wants to insert head. That is, it is going to insert the entire node at the beginning. Fine. So this is how it's going to work. So this head has a position of the very first node of the entire linked list. I'm just going to insert new node before the head location. Fine. So this is going to insert at the beginning of the location. Fine. So let's see. And then I'm just going to replace the node, that is new node with this node. Fine. So you can see I'm just going to create one node, then I'm populating the data into that node, then I'm going to insert at the beginning of this node. Fine. And then I'm just replacing my new node to a node which is a head location. Then after I'm returning this head location so as to work in a very efficient manner. So this is going to be step 4. Fine. So pretty much easier. Fine. Okay. So let's compile and see if there is some error or something. Build. Okay, so there's some error. Just a second. Okay, so minor error. Fine. Let's see. Build and compile. Okay, so finally it's been done. Let's execute the things. You can see first it's 2 and then it's 4. For pretty good printing, I'm just going to create one tabular file, or I'm just going to create this way, and then I'm going to print over here. Fine. So let's see. Again compile, build and run. Oopsie, just a second. Okay, forgot to write printer. Build. Okay, compilation successful and then run. Fine. You can see first it's 2 and then it's 4 and then it's null. Fine. Easier, right? Let's again build and then execute 2, 4 and then null. Fine. Okay, bingo. So how I'm going to start with one more thing, that is if I want to insert a node at any of the given location where I want it in a sorted manner, then how I'm going to do it. It's pretty much easier. So can I term this insert at the beginning? Fine. So I'm just going to use this as a begin, and now I'm going to insert at after location. Fine. Let's start with after. Struct node star node and integer new data. Fine. You can see each and every steps are being repeated at every interval of time. So in this, first let us see if the previous node is null or not, and then we will go forward. But for that, just a second. Okay, so I'm just going to create a previous node. Fine. Let's check if the previous node is null. Why so? Because if the previous node is null, then we cannot insert. The concept actually fails, that the one should insert the node after some null value. It doesn't make any meaning. Fine. So it doesn't make any sense also. So let's see if previous node is equal to null. Fine. That means the linked list does not exist. Fine. So in that condition, I'm just going to type some value. The given previous node cannot be null. Fine. And also I'm just going to return from here itself. Fine. Without returning any values, because it's void. Fine. So in other context, if the previous node is not null, then it's going to go forward by creating a new node. Obviously, struct node star, and then malloc function with size of struct node. I think it's pretty much easier. it's always going to be the same step for each and every insertion. Okay, just a second. Equal to new data. Okay, so this is how actually a new node flourishes. And then after node of next equal to previous node of next. Fine. I'm just going to show you this step in just few minutes. And node of previous node of next equal to new node. Fine. I'm just sweeping the entire memory locations. What I have done is creating a new node. Fine. I want to insert this node after this node, that is previous node. Fine. So what I'm just doing is creating memory location for this node, initializing new data to this data variable in the node, and then I'm just initializing. Okay, so where I was is just getting initialization of this node. After getting initialized node, I'm just going to previous node of next is equal to node of next, and node of next equal to new node. I'm just going to swap the entire stuff. I'm just going to write it node right here. Okay, so after that, let's see if it's going to work. But before that, I'm just going to type one more thing. This is step 1. Fine. To check whether the node is null or not. This is step 2. That is initializing, if it is not null, initializing the new node. After that, this is step 3. Step 1, 2, and this is step 3. Fine. After that, this is step 4. And then this is step 5. Yippee. Fine. Let's see if it's going to build or not. Okay, so it's building. Let's execute it. Oh, fine. Let's insert one. Okay, I haven't called this function. I thought I called it function. So let's insert this value at the second location. Insert 3 at after 2. So linked list becomes how we call it is 2, 3, 4, and then let's see if it does make sense or not. Build and then execute it. Oops. Oh yeah, I forgot to call this function. Insert at the second location, that is head of next. Fine. And then 2. So how I'm just going to fulfill the entire things over here. Build this thing and then execute it. Okay. Not found error. Okay. What was okay after? Right, sorry, just forgot to the name of the function. Build and then execute it. Sorry, it doesn't return anything also. If you wish, you can also do return some value to these functions. Okay, so you can see 2, 4, oops, I had 3 1. let's build it and see the output is desirable or not. Ah, yeah, right. It's going to insert after 4. Sorry, so let's insert 5 instead of 4. Build and then execute it. 2, 4 and 5. Yes. Okay, so insert 5 after 4. Fine. So it's going to insert 5 after 4. So this is how the output looks like. I think it's pretty much easier to understand in this context. So also let's try one more thing. Insert 1. Where do we want to insert? Okay, let's try at the beginning also, so we can test. So the linked list will become something like this: 1, 2, 4, and also we have 5, and then we have now 5. Okay, so if we want to insert it, let's try it. Insert head, comma 1. Let's try it this way. Okay, we need one more thing, that is head location to be taken care of. Have I done any mistake at this point or not? Let's see. Compile and build. Okay, build and execute it. Okay, I'm sorry, just some errors. After begin, yeah, right, sorry, I just changed the name of the function at the beginning. Okay, just a second. After begin and append. Okay, fine. Oops, sorry friends, just forgot to see that I just changed the name of the function. That is, it was an insert first, and then I just forgot that it's begin function. I just renamed it. So you can see the compilation has been successfully done. So let's see. It's 1, 2, 5 and 4. Oops, it should be 4 and 5. Let's see. First it's 4, then it's 2 at the beginning, and then it's 1 at the beginning, then that beginning, and then it's 5, but it should be, let's try it with 4. Okay, let's see. Insert 3 after 4, before 4 actually. Let's see. Build and then execute it. You can see 1, 2, 3 and 4. Fine, and after that it's printed to null. So first we are appending 4, then we are inserting 2 at the beginning, then we are again inserting 1 at the beginning, and then we are inserting 3 at the third location, that is not at 1, not at 2, but at 3. Fine. So third location before 4. Fine. Pretty much easier. Okay, so after that let's do one more round of 5. Head equal to append. Let's try once again append with head of 5. Let's see if it's inserting node at the end or not. Insert 5 at the end of the linked list. So it becomes 1, 2, 3, 4, 5, and then null. Fine. In this context, I'm just going to change 1, 2, 3, 4, and then this. Now let's see if it's going to work or not. Build and compile and execute. you can see it's 1 2 3 4 5 and then none. Fine. I have tried with different combinations of insert, update, append and everything. Do write me some feedbacks, but before that let me show it to you how you can run this program. Okay, so just going to pause for a minute. I'm just going to populate this comments also, and then I will show it to you and share a link with you people on how to do the programming, and you can copy and paste this entire thing. So just a moment, I'm just going to pause and populate these comments lines so that it makes much more easier for you people to understand the code. Fine. Okay friends, so after a lot struggle, I have just populated with each and every comment you might need to understand each and every factor. So let me just introduce this code to you. Entire code is right now done. Just going to share this code for you people. Let me first create some public sharing for you all people. Okay, so this is the link for it. I'm just going to copy it. Okay. I see if there is no mistakes in anything. Okay, done. Let me test it if it's working or not. My internet is quite slow, so it's going to take a while for opening it. But before that, it gets opened. Let me show it to you how it works and how we should run this file. This is my previous file, that is simple linked list that we have created in our previous video. You can see it over here. The entire code is itself shown over here. Fine. And this is my insert node that I have just created in this video. So just for your understanding, and if you want to do some trial error methods, you can do it in this code itself. So let's see. Just going to delete this thing. Okay, so just going to create new node. Okay, fine, it's done. Fine, so let me show it to you once again, the entire code. This is append function which has a time complexity of O of n. Why O of n? Because the entire for loop runs from the beginning to the end. So there are if there are n number of nodes, then it's going to take time complexity of n number of microseconds or milliseconds, or you can say O of n. Fine. In that way, this is the beginning function which is going to take the entire time complexity of O of 1, because it's always going to insert the entire node at the first location only, and so it doesn't matter. So if it's at the first location, or the time is in constant work for it to insert a new node, so obviously it's going to be in this manner itself. Fine. So O of 1. Once again, you can see the time complexity of after node is also O of 1, because it's a constant amount of work it's going to do. Fine. So this is also of 1, and the similar way, display function is always going to take O of n, because it's going to scroll each and every node each and every time. So it's going to take O of n number of times. Okay, so let's just edit this context for it to make it very clear for you people. Fine. So let's see how to compile this thing. It's very easy. In Linux we have GCC. Fine. And then I'm just going to create an object file for it. That is the object file, the name of the object file is InsertNode, and once again I'm just going to provide an what we call is source file to it. So this is InsertNode.c. just going to press enter. You can see the object file has been created over here. Fine. If you want to remove the object file, it's going to be in this manner. Fine, and you can see the object file is gone. Let me once again calculate it. Fine, and then press ls. So this is my object file right now in this context. How I'm going to run is / object file name, and then press enter. You can now see the entire work has been done. Just a second. Okay, let me clear it once again and then run. Fine, so this is how it's working. You can see 1 2 3 4 5 and then null. Fine, so this is how it's going to work. Once again, I'm just typing ls and removing this insert node. Fine, and then press ls. You can see there is no node file, so you can test it at your will, whatever you like it. Fine. Okay, so I'm just going to share this location. I'm also going to place this entire what we call is URL. Oops, I'm just going to paste this URL in description mode, and also how to run this program in the description. Do watch my videos. I'm just going to post more and more videos on this data structure, and I'm also thinking of creating a new channel for Linux systems also, so as to work in that way. Okay, just sorry. Fine, so thank you all. One more thing, now you can see the entire things. If you could not hear me very well, or you could not see it, you can see the entire code also. So it's going to be working very fine and very beautiful manner. This entire thing I have populated it in your convenience at your place itself. Fine, thank you all. Thank you for watching me. Do subscribe this channel, and yeah, please do tell me if you could not understand any point, then do comment me at the same location. Fine, thank you all.